Hello, and welcome back to Shiksa DaCosta. Today we're going to introduce you to a unit called Solving Problems that Involve Properties of Line Segments. In this unit, you're going to learn how to solve problems using a branch of mathematics called analytic geometry. Specifically, we're going to deal with lines and line segments. Throughout this unit, you are going to develop a bunch of formulas. One for the midpoint of a line segment, one for that line segment's length, and we're going to use those to solve problems. And then we're going to move to circles. So you're going to develop the equation of a circle with the center at the origin and a specific radius. And we're going to do that by extending our ideas about line segments. Then we're going to determine the radius with of a circle that has its center at the origin if we're given the equation. So these two are very closely related. And we're going to be able to write the equation of that circle. You will also be able to learn how to sketch the circle if its equation is given to you. And finally, we're going to use all of these ideas to solve problems involving the slope length and the midpoint of a line segment. To start off, let's talk a little bit about where we might see something like this pop up in real life. So weather balloons called transonsons, they gather meteorological data like wind speed, air pressure, stuff like that. And they send that data with the coordinates of the balloon back to the base station. How would this technology help scientists detect an approaching hurricane, for example? Pause the video here and think about this. And here's a little diagram to help you visualize what's happening. So let's say the base station is here. We've got weather balloons all over the place. And the only thing these weather balloons can do is detect wind speed and transmit the wind speed and the coordinates of the weather balloon back to the station. Well, one way we might see that happen is, let's say there's a weather balloon over here that starts sending when it's sending its data, the wind speed data goes pretty high above a certain level. So it actually starts signaling, hey, there's some high wind speed. Now this weather balloon might be floating around, right? That wind actually might be pushing it somewhere. And so we need to know exactly where it is. And its location is not always fixed. Thankfully, it's able to find its own coordinates, and it sends that information back to the base station, which then has to figure out, well, hold on, is this guy really, really far away, or is it close? Thankfully, with those coordinates, we might be able to locate, say, the distance east and maybe the distance north. And because cardinal directions meet at a right angle, they are perpendicular to each other, we can use this information to find the exact distance. Notice that these three directions, or these three lines, they form a right angled triangle. Maybe another weather balloon starts going off, and we need to find the distance to that weather balloon. And so generally here, because these cardinal directions that the coordinates have are perpendicular, that right triangle can be created to find the distance to any transonsond. Now, a signaling balloon with a low distance might indicate that there's a danger there. So if these two have gone off and we've measured the distance there, and then suddenly this one goes off, that's a little bit closer to us, that might tell us that, hey, this one went off first, then this one, then this one. There is danger, high wind speed, and it's heading in this direction. So coordinate grids are actually super useful for us to numerically, in other words, use numbers to describe information about points, about lines, about angles, and even about shapes. And we can even extend this idea not just on a flat surface, but we can even extend it to three-dimensional shapes. And we'll get to that, in our more advanced mathematical discussions. The reason we use them is because now that we can get that information about the point, about the line, whatever, we can use that data to find even more information. Like, hey, what is the center of the line between these 2 points, the midpoint? What is the distance between this point and this point? What is the length of that line? What is the area of the shape created by those 3 points or those 3 lines that connect them? What is the angle measure created by these 2 lines? All of these things can be found if we only have numerical information just about the points themselves. So we're going to explore these ideas a lot in this unit, and I hope you're ready for that. If you like this video, please like, rate, subscribe, and join our mailing list. And you can find this lesson as well as practice questions, solutions, handouts, and more on our storefront. Thanks and have a great day.